prove that root 2 plus root 3 is irrational. So very first thing is we are going to make use of proof by contradiction. So the idea is we'll assume, let's assume root 2 plus root 3 to be rational. Okay, that's good. So what can we do with this information? Therefore, root 2 plus root 3 can be equated to a rational result. We don't know what is the result, but we can equate it. So here x is a rational number. Rational number. Right, now it's time for simplifying things. So we'll rearrange and I get this. Then what is that we have to do? We have to square both the sides. So root 2 square is equal to x minus root 3 the whole square, right? This is on squaring both ends. So what happens to root n square? I think I have it in, yeah, right. What happens to root n square? So any root of any number is nothing but a to the power of half. So square is nothing but 2. So 2 divided by 2 will be 1. So basically they will get cancelled. That's what I mean. So we have root n square getting cancelled. Okay, and on the RHS we have a minus b the whole square identity to be used. Okay, I'm not going to expand it. You guys have to remember. So 2 is equal to a square plus root 3 square minus 2 into a into b. So here too we have the root and the square getting cancelled, right? A bit of simplification and we have the final answer. So basically I need to transpose this. See, this is the whole procedure. 3 minus 2. Let me write it off. Okay, all I'm doing is getting an expression for root 3. That is, I'm trying to equate root 3 to some expression. Okay, so the next step would be 2x root 3 is equal to x square plus 1. And then we have divided by root 3 on both the ends. Sorry, root 3, 2x. Dividing with 2x on both the sides. What do we get? So we have the final answer to be root 3 is equal to x square plus 1, always put it in brackets, divided by 2 into x. So what did we do? I just assumed it to be rational and then ended up with an answer wherein I have root 3 being equal to a rational expression. But we know that root 3 is irrational, is it not? We have proved this. We have this to be an irrational number while this to be a rational number. How is this possible? Why is there a contradiction? Right? This contradiction occurs because of our wrong assumption. So our answer is this contradiction of LHS being a irrational number while RHS is a rational number is because of our wrong assumption. Right, guys? So we assumed it wrong. Right? We started with a wrong thing. That's why we ended with a wrong scenario. Okay? And so we have which color? Okay, I think this. Therefore, we have root 2 plus root 3 is irrational. Okay, yes. Understood? That's how you do it. Always start off with the assumption. This is because of proof by contradiction. Right, that's the funda. This entire answer is we are proving by contradicting the actual thing. And so we got an expression and we have a bit of simplification over there, right? Rearranging and all of that. And we have LHS to be rational while sorry, LHS is irrational while RHS is a rational expression, right? So we have this two to be contradicting, is it not? So how is that we are equating two contradicting things, like equating 1 and 2, 1 is equal to 2? How is that this is possible? It's because of our irrationality in our initial thing, is it not? I mean, not irrationality, wrong assumption in our initial setup. So you started off with a wrong foot, basically, something like that. Okay, and then we corrected by yes, what we were telling was wrong, and let me correct that and tell yes, this is irrational. So that would be your answer. Okay, you can pause and have a look.